Hello everyone, welcome to DKodeTree. Let's solve LeetCode 167 two-sum 2 problem. This is just a variation of the classic two-sum problem. The key difference is that in this problem, the input array is sorted in non-decreasing order, which means the numbers cannot decrease as we go. And we need to find the indices of two numbers from the array whose sum will be equal to a given target. They have mentioned that there will be exactly one solution, which means the test cases will not include any duplicate numbers, and we may not use the same element twice. Let's iterate through an example to understand this problem. Note that the given array is one-indexed. Noted down the indices for better clarity. The brute force way to solve this problem is to go through every pair of numbers in the array and check that their sum matches the target or not. Let's check the sum of 1 with every other number. So 1 plus 2 is equal to 3. This is not equal to 7. So we will move to the next number. Now we will check 1 plus 3. The value is 4, which is still not equal to 7. Next is 1 plus 4 is equal to 5. This is still not equal to 7. Next we will check 1 plus 7 is equal to 8, which is still not equal to 7. But note that 8 is actually greater than 7. Since the array is sorted, the sum with the next number will also be greater than 7. So as an optimization, we can stop checking any numbers after this one. Now our array in consideration is only till this point. Now let's move to 2 and check its combination with every other number. Note that we will not check the sum of 2 with 1 again, as we have already checked the sum of 1 with 2 in the previous iteration. And this can be easily checked using this condition, where the first index is less than the second index. So we will be discarding this element as well. So now we only need to check the sum of 2 with the elements lying in this section. So 2 plus 3 is equal to 5, which is not equal to 7. Similarly, 2 plus 4 is equal to 6, which is still not equal to 7. Now 2 plus 7 is equal to 9. This is also not equal to 7, but it is greater than 7. So if any element was after this one, we don't need to check those as well. Now let's move to the next iteration. As 2 plus 7 was greater than 7, so we can discard 7 as well. As we have already covered 2, we can strike this out. Now we are at 3 and we will be checking whether 3 plus 4 is equal to 7 or not. And it is. So we have found our target and we can return the indices of 3 and 4 as result. So we can directly check the index of 3, which is 3, and index of 4 is 4. Remember, for this problem they have given one indexed array, so we have to return the answer accordingly. This approach does not need any extra space, so the space complexity is O of 1. And in worst case, for each of the n numbers, we have to iterate through the entire array. So the time complexity will be O of n square. Let's see if we can do any better. Notice that since the input is sorted, we are able to discard unnecessary elements from the beginning as well as the end. And this we can do using a two pointers approach in a more efficient way. So let's understand this approach. Say we have 2 pointers, left and right, where left is placed at the first index and right is placed at the last index. Let's calculate the sum of the elements pointed by the left and the right pointer. That is 1 plus 9, which is equal to 10. Notice that this element is actually greater than our target 7. If we move the left pointer, the sum will increase even more. So we need to move the right pointer to reduce the sum. Now let's calculate the sum again. 1 plus 7 is equal to 8, which is still greater than 7. So we will move our right pointer. Next is 1 plus 4 is equal to 5, which is actually less than 7. So in this case, we need to increase the sum. So we will move our left pointer. Next, we will calculate 2 plus 4 is equal to 6, which is less than 7. So we still need to increase the sum and we will move our left pointer. Now we will add 3 plus 4 equal to 7. And this is equal to our target. So we can return the indices of 3 and 4 as the result. The index of 3 is 3 and the index of 4 is 4 in this case. So this was the entire approach. And since we are scanning through the list only once, so this approach runs in O of n time. Also, no extra space is used, so the memory complexity is O of 1. Now let's code this up. As we discussed, we will take two pointers, left and right, where left will point at the first number and right will point to the last number. We will use a while loop with the condition left less than right, because if they are equal, they will point to a single number and that is not what we want. Now let's calculate the current sum, which is equal to the number at left index plus the number at right index. Now, if the current sum is greater than target, we will be moving the right pointer, that is decrementing it. And if the current sum is less than target, we will move the left pointer, that is incrementing it. Otherwise, it means that the current sum is equal to the target, so we can directly return the result. The result will be the indices left and right. But as the input is one indexed, so we have to add 1 here accordingly to get the result. As there is exactly one solution, so this return statement is not necessary and the inner return statement will definitely execute. Now let's run this code and check if it works. And we can see that this is working and it's quite efficient. If you found this helpful, leave a like on this video and subscribe to DKodeTree. Thanks for watching. See you in the next video.